And today our topic is angles of elevation and depression. So let's first go by angle of elevation. So elevation means like something that is above another thing. That means the thing is elevated above that thing. So the surface, like something is above, a stone is hung above a table. So you can say that stone is elevated above that table. So elevation is referred to the height of an object or a point above a reference level. For example, above the sea level, above the table surface, above the building floor, and all that. So let's look at some scenarios. Imagine a person standing on the ground and looking up at the top of the tree. So let's say this is our person. Right here is our person. So this is our person and is looking at the top of the tree here. Here's the top of the tree. So the angle that is formed with a line of sight and the horizontal. So you see that the horizontal is the line, a horizontal line, a straight line that passes through the person's eye. That's the horizontal. So it's not the line under the person's feet. It's the line that passes through the person's eye. That's what is using to view the tree. So the line of sight is like the line that connects the top of the tree to the person's eye. So the angle that forms between the line of sight, which is the line that connects the top of the tree to the person's eye, and the horizontal, that's a straight line that passes through the person's eye, is called the angle of elevation. So we can say that D is our angle of elevation here. So this is our angle of elevation. So you can see the picture clear here. So this is our line of sight. This one is our line of sight. A line that connects the person's eye to the what? The top of the tree. And the horizontal is like a line that passes through what you are using to view the tree. So in this case, you are using your eye. So this, the horizontal, is like any straight line that passes through your eye, a straight line that passes through your eye. So the angle that forms between this straight line and the line of sight is called the angle of elevation. So our angle of elevation is here. So this is another picture. A man viewing or seeing the top of the tree was 4.2 meters away from the tree was 4.2 meters away. The sight line, that's the line that connects the person to the top of the tree, the person's eye to the top of the tree. I don't know. So this is the top of the tree, and this line that connects it to the viewer's eye. So this is the viewer's eye. So the viewer is here. So this line that connects the top of the tree to the viewer's eye is called the line of sight. And the line that passes through a straight line, this one is not straight. So the straight line that passes through the viewer's eye is called the horizontal. So this is our straight line. So this line is called the horizontal. So the angle that is between the line of sight and the horizontal is the angle of elevation. You can see clearly that that angle is above or elevated above this horizontal line. So that's why we call it angle of elevation. That means the angle is above the horizontal line. So why do we use or what do we use angle of elevation for? Aviation industry, like the pilot, those who are flying the planes, they used to calculate the slope at which they should slope the plane when they are landing. You know, when they are landing, the cockpit, I mean the front part of the plane must come down and the top one will be on top, like the tail part will be on top. So they have to calculate this angle in such a way that when they are coming, they will not come and collide with the ground. They will calculate in such a way that the tires will come and land appropriately. And telecommunication, like this one is used in communication industry. Like if you buy a TV, there is the plate that you buy. The plate, you see that they don't just place it there, they adjust it to an angle that it can pick signals from the sky, the satellite that is in the sky. So they use angles of elevation to do those things. So let's solve some examples of this topic so that you better understand it. So we have a question here that says a person stands 30 meters away from a building. So 30 meters away from a building. So this is our building. So the person standing 30 meters away from it. So this the person. Here's the person. And he's standing 30 meters away from the building. And the height of the building is 50 meters. So let's say this building is 50 meters. This building is 50 meters, like this height is. So let's say this 50 meters. Building. So this is our person here, and this is the building. So let's say this building is 50 meters, and the distance from this building to um here, this place, the person is 30 meters. That's what they're saying. So what is the angle of elevation from the persons to the top of the building? So this the line of sight, this line is the line of sight. So this the horizontal. So what they're asking us is the angle between the line of sight and the horizontal. So they want the what angle of elevation. So let's solve for it. So solution. So what you need to do is you see this a kind of triangle. So we use the height of the building is a straight line, the line of sight is also some diagonal line, and the distance from the building to the person is a horizontal line. So when you combine all this, you get a triangle. So first we draw our triangle like this. So they said and the height of the building is 50 meters. So we put our 50 meters here. And they said the distance from the person. So let's say here is the base of the building. If here is the base of the building, then um here is where the person was standing. Here's where the person was standing. So the distance from this place to the building is it was 30 meters. So we have to put our 30 meters there. So so this now our line of sight, this line, this is the top of the building. So this is the line that connects the top of the building to what? The person's eye. So this is the person's eye. So this is the line of sight. So they want the angle between the line of sight and the horizontal. So this is the angle that we are talking about. So this is the angle here. So first we have to let the base of the building be A. So here is the building. So here is the base. And also let the point at which the person was standing be B. So here should be B. And also the top of the building is here. So it should be what? C. And our angle of elevation should be X. The angle of elevation should be X. So we are going to put our data that we are those who introduce. So we have to put in the triangle. So first put A here, put A here, then we'll put B here, then we'll put C here. Then we'll put X here because we said the angle of elevation should be X for the meantime. So we'll put X here. So looking at what the data we are having, we see that we are looking for this angle and we are having two distances. The height of what? The building and the distance from the base of the building to where the person was standing. So these two distances, we are going to look at the relationship they are having with our angle. So we see that this distance is opposite to our angle. And this one is adjacent to the angle. So looking at these two things, opposite and adjacent, we'll be using the tan. because tan we can accommodate opposite and adjacent. So tan of our angle x should be equal to opposite, which is the 50, over adjacent, which is 30. So what we want to do is like we want x, not tan x. So we are going to make sure that x stand alone. So we want x to stand alone. So what we can do, we can divide both sides by the tan and leave x alone. If you do that, we are implying that the tan is multiplying the x. So this is not the case. The tan is telling us that the ratio of the height and the distance is 50 over 30. That's what the ratio is telling, the tan is telling us. It's telling us that the ratio of um, this angle, for this angle, its opposite and its adjacent are in this ratio, 50 over 30. So what we do is we use tan inverse. So we say x equal to tan inverse of these two numbers, this provision. So x equal to tan inverse of 50 over 30. So here we have arctan. Arctan means tan inverse. So this one can be read basically like x equal to tan inverse of 50 over 30. And we can use our calculators to find this. So or using our calculator, I think we'll get something like x equal to 59.04 degrees to 2 decimal places. So we were not asked to find x. We were asked to find the angle between the angle of elevation. That's the angle between the line of sight and what the horizontal. So after we brought our x, so after that we have to tell them that the angle of elevation is equal to 59.04 degrees. We don't have to leave our answer in the x form. So another question. An observer is looking at the top of a tree with an angle of elevation of 30 degrees. If the observer is standing 40 meters away from the tree, what is the height of the tree? So this one is not asking us of the angle of elevation, but rather they gave us the angle of elevation and they want to know the height of the tree. So let's look at the tree. So let's say this is our tree and the observer was standing here. And let's say the distance from the observer to this tree was what? 40 meters away. And this angle was 30. This angle here was 30 in the question. So this our angle was 30. So what they're asking us, they want the height of this tree. The height of this tree is what they're looking for. So let's solve this particular question. So this is also a kind of triangle because the height of the tree is a vertical line and the distance from the tree to the observer is also a horizontal line. And the line that connects the top of the tree to the observer is what? A diagonal line. So when you combine these three things, you get a right angle triangle. So our solution will first draw or represent the information in the form of triangle to make it simple for us. So draw our triangle here. And they said that the height of the tree, we don't know what the height of the tree is. So the distance is what we are given. So we said the distance was 40 meters. So here's the distance here. So here is where the observer is. So the distance to the tree here was what? 40 meters. So put our 40 meters there. And this is the angle. So we were given that the angle of elevation, that means the angle that's above the horizontal line. So this is the horizontal line and the angle between the line of sight. So this is the top of the tree and this is the line of sight because this line connects the top of the tree to the eye of the observer. So this is the observer's eye. So this line connects the top of the tree towards the observer. So this angle between these two lines is called what? The angle of elevation that was given in the question to be 30 degrees. So put our 30 degrees here. So we have to name this triangle so that when we are come to talk about it in mathematical terms, we will know how to say it. So we say let the tree position be what? A. That means the base of the tree should be A. And the observer position should be what? B. And the top of the tree should be C. And the height of the tree that we don't know, it should be Y. So this length should be Y. The height of the tree should be Y. So we have to input our variables: A for the base of the tree, B for the what? Position of the observer, and C and for the top of the tree, and Y as the height of the tree into the diagram. So let's put A here, put B, and put C, and put Y there. So we see that we want the opposite of this angle, which is Y. The height is the opposite of this angle, so we want the opposite, which is O. And we were given what? The adjacent. That's the distance that we're given. So it's adjacent to this angle. So this 40 meters is adjacent to this angle, so it is adjacent. So you're looking at having O and A. Looking at SOHCAHTOA, where can you find O and A? You see that you find it in tan. O and A, that's opposite and adjacent. So we can't use the so or the sin because we don't like in the sin we don't have adjacent, but we were given the adjacent. And in cos we have adjacent, but we don't have opposite. But we are looking for opposite, so we can only use the tan. So we know that tan is the opposite of our adjacent. So the tan of this angle should be equal to the opposite, which is y, over its adjacent, which is 40. So we say tan 30 should be equal to y, our opposite, over what? 40, our adjacent. So this one, we have to cross multiply or something because we want to make the y stand alone. So cross multiply by what? The denominator, which is 40. So cross multiply by 40. So you see that 40, when you multiply 40 by tan 30, this is what you get: 40 times tan 30. And you assume that the tan 30 was over 1. So the y will multiply that over 1 and give us only y. So we are saying y equal to 40 times, this our times, tan 30. So at this point, we can use our calculator to do it. So I think our calculator will give us something like y equal to 23.09 meters to 2 decimal places. So, but we weren't asked to find any y. There's no any y in this question. What we were asked to find is the height of the building. So we must tell them the height of the building. No, we are not telling them why. We are telling them the height of the building. So we say therefore the height of the building is 23.09 meters to 2 decimal places. Yeah, therefore the height of the tree is 23.09 meters to 2 decimal places. So this is our third question. This one is: a ladder lays against a wall, forming an angle of elevation of 45 degrees. Here too, we are given the angle of elevation, which with the ground. So the angle of elevation was formed with the ground. So right now, we don't have any line of sight. This one is a ladder. The line of sight is represented by the ladder. So if the top of the ladder reaches the height of 10 meters, what they are trying to tell us is that the point at which the ladder touches the wall was 10 meters high. So if you are solving it, we'll consider only 10 meters, not all the height of the wall. So the height of the wall is 10 meters. And the angle of elevation was 30 degrees. And the question is, what is the length of the ladder? So let's view this and analyze it. So this is the ladder. So this is the ladder. And at this point, you can see at this point to the down is 10 meters. So, and the angle that the ladder form, you see this angle, the angle that the ladder form with the ground is 45 degrees. So, what is the length of this ladder? That's the hypotenuse. You can see the shadow has formed a triangle. You see, this is the straight line, this, and this. The ladder is the hypotenuse of the triangle. So we will represent this diagram by what? A triangle. So in our solution, we draw our triangle. So in this case, this is the wall. So this is the wall. So this is the height of the wall. And this is the ladder from the wall to the ground. From the wall to the ground here. Get it? So this is the distance from the wall to the ladder to the wall. So the angle that is formed here, this point is the 45 degrees they are talking about. And this length is the 10 meters, the length of the wall. The wall is straight, but the ladder was leaning against it. It wasn't straight so that someone can climb it. So we have to input what we're giving into um, the triangle. So we're given that the height of the wall is 10 meters. So put 10 meters here. And the angle of elevation, we're also given that it is 45. We'll put our 45 there. So we weren't given the rest. So let the position of the ladder be what? A. So here should be A. Now the base of the wall, here rather should be A, and here should be B. Here should be B. And the point at which the ladder touched the wall, this point, the wall continues, so, but this is the point at which it touches the wall. So let's say the wall continues to this place. So from here to this place is the 10 meters. So we'll put C here. So we'll input. So the length of the ladder 2 is what we are looking for. So we must represent it by a variable so that we can work with it. So we will let this one be y. So we put A here, put B here, put y here, and put C here. So what do we want? We want the hypotenuse. That's the length of the ladder, and it is the hypotenuse of this triangle, the longest side of this triangle. So that's the y. That's the length of the ladder they want. So and it is the hypotenuse. And we were given what? The 10 meters, the height of the length, which is opposite to this angle. So this 10 meters is opposite to this angle here. Opposite. So we are going to use the sign. You see that looking at the provisions O and H. H and O can only be found in the first one, the so, which is um, sine theta equal to what? Opposite of our hypotenuse. So the theta right now is 45 degrees. So sine 45 degrees should be equal to opposite. Opposite is the 10 meters and the hypotenuse is the y. So it should equal to um, 10 over y. So this over 10 over y. So proceed. So at this point, we'll do cross multiplication. We'll cross multiply because we cross multiply by the denominator of this fraction here. This fraction here. So what we do is multiply and y by what? The sine 45 and the 10 by the one that is supposed to be under here. So the 10 multiply. So we get something like y times sin 45 equal to 10 because the 10 is multiply only one. So at this point, we want y, not these plenty things. So divide both sides by what we don't want. So this is what we don't want, the sine 45. So divide both sides by this to eliminate or to make the y stand alone. So divide both sides by sine 45. and we get y equal to 10 over sine 45. So y should be equal to what? 10 over and time 45. So use our over. So 10 over sine 45. So these are over. That's over sine 45. So the calculator will give us y equal to 14.40 meters. That means that the ladder was 14.40 meters tall. So we don't have to give them y because in the question there's not anything like y. So we have to tell them that the length of the ladder, that's what they requested for. So therefore, the length of the ladder is 14.14 meters to 2 decimal places. So now let's take angle of depression. To depress something in this context, that means in this mathematical context, not the depression we are having every day. It means that to place something below another thing. So if you place something below another thing, you have depressed it under or below that thing. So talking about angle, we are talking about angles that are formed below the horizontal line. That's the line that passes through the viewer's eye. So the angle that is formed below that horizontal line is what? Angle of depression. Angle of depression. So the angle is depressed below what? The horizontal line. So we are come to look at some properties. The line of sight. The line of sight is the line that connects your eye to where what you are looking at. So your eye to what you are looking at is the line of sight. And the horizontal plane is a line that a horizontal line, a straight line that passes through your eye. It's the horizontal line. So let's look at this scenario. Imagine a man standing on top of a building and looking down at a ball on the floor. So this a boy standing on top of this building. So this is the building. This is the building, and this the man. So he's looking at the ball here. So you see that this the line that connects his eye towards the ball. This line connects his eye to the ball. And this is a horizontal line that passes through his eyes. This is the horizontal line that passes through his eye. You get it? So the angle that is formed between the horizontal line and the line of sight is the angle of depression. So this is our angle of depression here. Here is the angle of depression. So you see that the angle is below. In the elevation, the angle was always above this horizontal line. But this one, the angle is below, so it's depressed below the line. And this is because the person is looking at the thing below. So the angle must be below. Like if he was looking at the thing above him, like he was looking at the thing above him this way, you see that the angle would have been formed somewhere here. So in this case, it will be angle of elevation, not depression. But as soon as you're looking at the thing below, the angle is formed below and it is angle of depression. So this one is saying a boy on top of a lighthouse watching his friend below. So this is the boy and this is the lighthouse. And he's watching a friend below. So as soon as you are watching something below, the angle that is formed will be depressed below the line, the horizontal line that is passing through your eyes. So as soon as you are watching something below, the angle to below it will be depression. So we are going to solve some few questions so that you better understand the concepts. So this question is a person is standing on a 50-meter high cliff. So let's show the picture. So you see this is the cliff. This is the land coming. This is the land coming from, and suddenly there's water. So this one is the cliff. The land that is cut is the cliff. So this man was standing on the cliff, and the cliff was what? 50 meters high. So from the bottom of the water to the land is what? 50 meters high. So, and the person was looking at what? A boat. So a boat, there was a boat somewhere here, and this person was looking at that boat. So what is the angle of depression from the person to the boat? So cliff is like um, the land that is above the water. So this is the water and this is the land. So from the distance from the base of the water to where the person is standing is what is 50 meters in the question. The question is 50 meters. So they said this person was standing on the cliff and was watching a boat. So the boat is somewhere this area and the person was watching it. So the angle that was formed, you know that as the person was watching it, the line that passes through the person's eye is a straight line like this. It's a straight line. So and the line that's connecting his eye to the boat is a diagonal line. So where the two lines meet, it will form an angle below the straight line. So that line is the angle of depression. So we are going to solve this. So this is the cliff. This is the cliff that is 50 meters. And this here is the boat. So here is our boat, the location of the boat. So this person was standing here and was watching this boat. So this is the line that connects the guy's eye to the boat. And my God. And this is the horizontal line that passes through the person's eye. It's a straight line that passes through the person's eye. So this is the line. So the angle that forms between the line and the line of sight and the horizontal line, this angle here is what? The depression. Yeah, that's the angle of depression. So um, we have to input our data. 50 meters is here. That's the height of the cliffs. And they said the distance from what? The base of the cliff to where the boat was is 120 meters. We have to put it there. And the cliffs, the angle of elevation, we don't know. So we just say that we should let the angle of elevation be what? Something like. So this is the top of the cliff, the top. So let the angle of elevation be what? Y. So that means this angle is Y. So we put our Y here. And you see that this one, to make it simple, we can bring this Y here because we know that if two lines are parallel in mathematics, this line and this line here and this line here are parallel lines. So alternate angles are equal. Angles that are on different lines or side of the line, you see that this is the transversal line. So you see that this one is at the right side of the line and this angle is at the left side of the line. So they say that they are alternate, they are alternative to each other, so they must be equal. So first, the height is the opposite. We are giving the opposite of this angle. So we are bringing this y to this place. But we can also solve this in this way. You can choose to form a triangle like this. Triangle like something like this. So we're not going to do anything like that. So we just have to understand that this angle and this one is the same. So we just have to put our y there. So the distance is adjacent to the angle. So if this is our angle, then this distance is adjacent to this angle, and this is opposite to this angle. And we want y. So y is equal to angle ABC. So ABC. So this angle, that's what I say. So we must put our y here. So put y there. So looking at what we have and what we want, we have A here. We have A here. That's clearly in TOA. That's tan. So I'm going to use tan. So tan of the angle, so tan y should be equal to what? Opposite, which is the 50 of what? 120. That's the adjacent. So tan y equal to 50 over 120. So here we are looking for, so find the tan inverse of this. Find the tan inverse of this. So y equal to tan inverse of this. So y equal to tan inverse of 50 over 120. So we can use our calculator to get this. So y should be equal to 22.62 degrees. So the angle of elevation that is formed here, that is the same. So whatever is formed here should be here. So as far as we are having our y here to be what? 22 over 62 degrees. That means here to is 22 over 62 degrees. And this is telling us that our angle of elevation or a depression is approximately 22.62 degrees. So the second question is, a lifeguard sitting on a 6-meter high chair. So a lifeguard is someone who's taking care of public swimming pools. Like in case of anybody want to harm anybody over there, he's there to guiding the people, taking care of the people. So the chair that he was sitting on was 50 meters high, no 6 meters high. So this chair is 6 meters high. And the lifeguard he saw someone in this swimming pool, and the angle of depression from the lifeguard eyes to the swimmer was 30 degrees. So what is the distance from the base of the chair to the swimmer? So let's say this the what? This is the lifeguard chair, and this is where he was sitting on top of it. And here is where the swimmer was. Here is where the swimmer was. So the line that connected the lifeguard eyes to the swimmer is this line. So this is the line that connects his eye to the swimmer here. So they are asking us to find um, the swimmer to the base of the chair. So here is the base of the chair. So we have to connect this distance is what they are looking for. The distance that connects the base of the lifeguard chair towards the swimmer. So we input about 6 meters as the height of the chair. So this is the height of the chair, and we label it. So this is the horizontal line that is passing through the lifeguard eyes. The horizontal line that is passing through his eyes. So the angle that is formed with the horizontal and the line of sight, the line that he used to see the swimmer, is called the angle of depression. So we are saying that alternate angles are equal. So this angle here should be equal to this angle here. So we can equally bring this 30 to this place. So let y be the distance. So here should be the distance. So put our y there, and we are given the opposite, and also the angle of depression is 30. And we want the adjacent, which is A. So looking at these provisions, you see that we are having opposite and adjacent. Y and 60, they are opposite and adjacent to this angle that we are coming to use. So using the tan, so tan 30 should be equal to 6 over y, which is opposite over adjacent. And what? When we cross multiply, the y will multiply the tan 30, and the 6 will multiply 1. So divide both sides by tan 30 to make the y stand alone. So y should be equal to what? 60 over. So this over. So 6 times 30. 6 over times 30 is what we are getting. So in our calculator, we get that y is equal to 10.39 meters. So therefore, the distance from the base of the chair to the swimmer is 10.39 meters.